Ross Spencer, an independent preservation researcher up in the National Archives.
Yeah, previously for the National Archives.
Okay. Well, we're interested to hear what you have to tell us about.
Thank you. Well, first of all, if I just point out that this is basically something I've been doing in my spare time, so I don't know what that says about me. The concept of this research paper is basically to create files with the minimum amount of data included in them, which will trigger an identification in tools such as droids to tell us that identification tools are doing what they're supposed to be doing. For anyone playing along in Twitter, my Twitter handle is @beatkeeper, beats_keeper. The concept's really simple. If everyone opens up their hex editors now and types in cat8bay, saves that file, runs droid against it, droid will identify it as a Java class file. The idea of this project is to just take that a little bit further and create those types of objects for every single digital signature in the program database. Program contains signatures that look a little bit like this. The program approach complicates the signature by adding regular expression syntax, which I've highlighted in red here. This particular sequence, if you focus on the part of the syntax in the round brackets, suggests that we can create two different skeleton files from this. One file on the left would look like this, and one file on the right would look like this. The difference between the 0A and the 0B, 0A. The rest of the syntax that makes up the rest of the regular expression syntax available to us is outlined at the bottom. So I created a tool that will go through the program database. First of all, you have to download the program database via XML. There's a tool available for that on my GitHub. This tool will then read the XML, extract all of the signatures. It takes under a minute to go through 946 program records as of signature file V66. There are 537 formats with signatures, and each of those formats will have one or two signatures attached to them, and we create 672 files. That's not the end of the story. The tool's in the beta stage at the minute. We're only creating a small percentage of the total number of files that you can have in the program, but I'll explain that later. So if you want to have a look at GitHub, all the code's available, yeah, you can play with that. From that work, I've created two sample test suites. So the thing we're talking about here, so basically a single file representing every single format in program. That work has uncovered these issues in program. 13 duplicate identifications, 2 regular expression bugs, and 1 droid's nuance put there. 13 duplicate identifications were due to one of two causes. Either the records had the same signature, 2 records had the same signature, and those who were involved in the TIFF debate about a year ago will recognise the problem there. And also, other duplicate identifications might be caused by sequences in the program database containing subsequences which match other file formats, so you get duplicate identifications there. They've all now been fixed. If you look at the release notes for program and droids, I've been in correspondence with them, and they've taken my work and they've improved the database as a result. The regular expression books were more interesting. These were 2 file formats that, if you were using Droid 4, you would have found everything matched perfectly. But the curly bracket syntax at the end basically says that the final part of the sequence in the signature can be found so far back in the file format. And in Droid 6, putting that bit of syntax there no longer works. Now, in program, there are 2 different ways of saying the same thing here. And so what the National Archives have done is fixed it by using a workaround, the workaround of doing it the other way. Why I like this book and why I think it shows the value of the test suite is that if this test suite had existed as a unit test within droids between the development of Droid 4 and 6, it would have been spotted. You would have found 2 files between Droids 4 and Droid 6 and no longer identified. And so the developers, I wasn't a developer on Droid 6, I was a developer on Droid 6.1. would have found that they needed to fix something. And similarly with the Droid, Droid Unity discovered here is we've got this issue where you've got two different types of identification now. You've got a standard identification, which uses basic binary signatures, and a container identification, which is triggered by only 2 and zip-based formats. It will go to a different signature file, identify the files differently. But if there's no identification, there's no fallback to the standard identification. This is something that's primarily discovered by running the test suite across it. And I think, again, if you were to incorporate this test suite in the Droid code base, between Droids 4 and 6, it would have raised a question for the developers about why these files weren't being recognized. And as I said, the work I've done is kind of all the way back to the National Archives and back again, and the program database is a bit more stable thanks to the work. This is an automated approach so far to developing these files. It's really important to also create these files manually. So again, open the headset to type in Cafe Bay and start working on the signatures that way. The methodology would be really simple. You create your signature, you test it alongside the skeleton suite, looking for duplicates. You test it alongside your sample files, making sure the signature works, and you then submit the signature, possibly with the skeleton file, to somewhere like the National Archives, and then it gets hosted. The idea would be for the skeleton suite to be hosted by someone else, probably other than the National Archives, but it could also be hosted by the National Archives, there's no real problem. Communication is really important throughout the entire process, but the importance of creating manual files is you will find things that won't work, and you might need to talk about them in a different way. Using the automated approach, only create skeleton files for stuff that works in Pronom, or should work in Pronom. If you were to create a signature that everything about the regular expression that you wrote says it should work, but it doesn't work in Droids, then you've got a file there that can be incorporated into a new unit test in Droids that come the next development of Droids, the developers can run the signature file with the skeleton file, make the test work, and then you fix a coding error in Droid. And so the automated approach to creating skeleton files alone really won't work. You have to do something manually, but there might be a bit of an overhead to that. In terms of hosting and licensing, in the paper I've described basic Creative Commons attribution share alike license has been appropriate for this. It's basically, I think it removes a single point of failure in terms of if you're working on signatures and skeleton files, you could host the skeleton suite for yourself, you just have to release it under the same license, you can make the changes to it, and yeah, you just have to attribute the original source. I think it's a really nice license for this thing, and there's no reason for the skeleton test suite to not host it and do that. GitHub score report, this is not the page you were looking for. Well actually, I think it might be the page you're looking for. If you look at the Planet's test corpus, I think the Planet's test corpus gives us a great model for being able to host binary files, download them easily, contribute to the corpus. And the skeleton suite, you could adopt a similar thing. I've basically created a simple repository here. I've used a name convention to clearly identify the files. You can have problems data. The history shows what you've done to change certain files. Every time there's a signature release, you can create a new tag, so you can have a tag per signature file per skeleton test suite. So GitHub, I think, is a really nice solution for hosting something like this. The benefits, or where it's not always possible to submit sample files to the National Archives to show your workings, especially if maybe restricted collections contain sensitive data. The skeleton file might be all you can have. The National Archives can do what they want with finding other sources of information, but the skeleton file is certainly a good start to show how you can work with things. The suite is like about 3. It's easily distributable, it's like 400K. In stabilizing Program Droid, you actually stabilize FIDO, which uses the signatures from Program Droid, but it might also be something that you might want to approach doing FIDO in the future as well. 672 files created in under a minute, which is something almost impossible with manual files. And we've demonstrated value so far in terms of droid v-droid nuances. Failings it's a little artificial. If you were to type this into a notepad window and say that it would identify Android as PDF 1.4, is it a psychological illusion whether that's good enough or not? Should be artificial about it. Smaller set. We only create a small set of files when we do it automatically. A signature change means a change to the test suite, a change to the unit test, and a change to the Droid code base. And it only sets identification mechanisms, and it's really important to test validation mechanisms too. As I said, I've been doing this in my spare time, so if you find a way to my GitHub page, have a look at the wiki there. There's more information about this work. There's an outline of the methodologies, how I think it would work. There's 2 sample test suites, and then there's 2 testing reports of the work I've done with those 2 test suites with the National Archives. So, conclusion, bit of a misnomer because there's quite a bit left. The original false alarm system was by Featherson and Gollins last year, and I presented it here at IBCC for them. I thought this might be an intermediate, sort of intermediate approach to creating a test corpus, but I actually think it might be complementary. There are no IPR issues, it's easy to host, it's easily licensed and easily distributed. But the false alarms also talks about creating a test suite that you can use for identification, validation, and a model that I'm seeing quite frequently recently is feature extraction. And I think it's still really important to have a test suite for that. But I'll demonstrate in a second a big problem with creating a test corpus full of a fully fledged test corpus, as I've been calling it in the test paper. So I also conclude the report by talking about the things that the test suite doesn't do, that the automated approach doesn't do. And at the minute, if you look at the round bracketed syntax, we only, what that means is you can have a 0, 0, 1, 0, 2, 0, 3, or 0, 4. It will only take the first of those and create, so it will create a file that looks like that with a 0, 0 and a 0, 0. It doesn't do the rest. If I were to naively take that syntax and try to convert it automatically into more skeleton files, I could end up with 30 skeleton files, 5 by 6 different options. But what those 2 bits of syntax represented was profile ID within the SPIF file format, and one profile ID is for byte-level images. The second bit of syntax represents the compression types you can have in the SPIF file format. And there are 5 of those apply to byte-level images only. So I'm not needing to create 30 skeleton files, I'm only needing to create 13. But the signature actually can't express that. So there's a failing when you do it automatically compared to how you do it manually. However, if you take this a little bit further and you think about being thorough in your approach to creating a fully fledged test suite, I think you can start to see a problem that might exist here. If you look at the header for this bit file format and you take out of that header the options where you can create multiple configurations of file. So I've selected the profile ID, bits per sample, compression type, and the resolution units. And then you have a look at how they're broken down between byte-tonal images and continuous tone images. And then you think about how you might create all those different configurations of file for testing feature extraction and validation. And you end up with 135 example test files for a fully fledged test suite. This is before I take into account the 15 different color space components that you can have in a SPIF file format, and before you take into account that this is a single file format. If you want to create a test corpus for all of the file formats, the thousands that exist out there, I think this work has demonstrated there may be an issue with doing that. I think there's a certain amount of metadata you need to record what these files are telling you, and I think it will take up quite a lot of space. And I think instead of just dropping this data on someone's data grid, I think you're starting to think this needs a fully fledged archival system just to store your test suite. So I think we've learned this. This is where I'm thinking about taking this work. Anyway, so where next? I don't know actually. We've demonstrated immediate impact. There's greater stability in the pronoun code base already. What's the last one? And And I believe there's lessons to be learned from this, and I hope when you read the report you might find a few things to take away from it for yourself. What's the best return for our investment though? I've taken the automated tool as far as I can. Manual generation, I think there's a massive overhead in 3 different areas. If you're creating signatures and skeleton files, that might be quite a lot of work. I think if you're the National Archives giving them signatures and skeleton files, that might be a lot of work for them, but I'm not going to speak for them. And if you are hosting a skeleton file, that doesn't exist, so that needs to be created. I think there's an overhead there. So actually, I'm not sure where to take this work. Someone has to pick this up and run with it, basically. To take it further, you also have to think about container formats. That means creating zip-based formats and only 2-based formats. The zip-based formats are trivial, but only to you're starting to look at specialized libraries in Python and how you create them manually. Maintenance of the suite will be quite difficult. It does require quite an analytical mind, and like I said, metadata and things. I think the logical next step might be integrating it into the Droid code base. When I have development ability, sometime in the near future, I hope to write a unit test and just demonstrate working alongside Droid. I think there might be value in that. With that, I just have the acknowledgements. Richard Brennan, he's an excellent contractor and an excellent developer. I've had the privilege of working with twice at the National Archives, and he was working on the Droid 6.1 project with me. And he started pioneering the use of these skeleton files within Droid anyway, and helped me understand the value of such a task suite. Nico Wells, digital archivist at the National Archives, such an intelligent and clear thinker, helped me understand the importance of this work in terms of, especially in terms of not underestimating what this can teach us about programming as a data set. And that comes from 2 different angles. There's a developer consuming programming as a data set, and then also from the skeleton task suite. Skeleton task suite telling us the quality of that data we're dealing with and how to improve some of that data we're dealing with. And then David Clipsham, who's a good friend and who also I've been in contact with at the National Archives to do this improvement work. And with that, I thank you. That's all I have.